Hi, my name is Ching Wei Lun, and my group members is Keng, Danarajan, and Farah, and we are from Group 1. This is our project presentation video. So let's start with the introduction of this project. So the deposition method we choose to review in this project is the electrochemical deposition method. This is the process of depositing conducting or semiconducting material onto the surface of a substrate using electric field and redox reaction. Next, why the characterization is important? The characterization study of a material is important to know the particular knowledge of a material. Through characterization method, we can know that the material is if it can withstand high temperature or how is the behavior of the material. So the three characterization that will be reviewed in this project is morphological characterization, electrical characterization, and the optical characterization. Next will be the literature review of electrochemical deposition. So the material that we use to fabricate is the zinc oxide thin film. It has a characteristic of high conductance, inert and stable at high temperature in air. And the zinc oxide have a lot of applications such as photovoltaic, transparent conducting electrode, catalyst, photoelectric material, photodetector, and also LEDs. This zinc oxide also have a lot of method to fabricate it, such as sputtering and CVD. And this method is in high pressure environment. And for atmospheric technique is spin coating and also electrochemical deposition. And this electrical chemical deposition is show that will be more effective to fabricate and also is low cost. There is other technique to fabricate this zinc oxide thin film, such as sputtering, but although the maintenance fees will be lower, but this electrochemical deposition has more application compared than the sputtering. Next is the methodology of electrochemical deposition method. So the material that we use in this method is the electrolyte will be the dilute zinc nitrate, the catalyst will be potassium hydrogen perlite, which is the PHP, and the electrode for positive terminal will be zinc plate, and the negative terminal will be the thin stainless steel foil with coated silver. So this is the image of the setup of the electrolysis process. So this electrochemical deposition process, also known as electrolysis process. During the electrolysis process, the solution temperature will be maintained in 76 degrees Celsius, and the current flow will be controlled at 1 milliampere per cm square. And the catalyst PHP will add through the range of 0 ppm to 12 ppm to observe the result of the zinc oxide deposition. The ppm is stand for part per milli, also can express as milligram per meter. Is a unit to determine the concentration of the chemical solution. Next will be the result of the deposition. The result of the deposition of zinc oxide will be observed by using SEM, and the catalyst of PHP will be added through the range of 0 ppm to 4 ppm to absorb or observe the quality of zinc oxide flake. So here is the result of the zinc oxide flake. For picture A is only have 0 ppm PHP, and photo B is 4 ppm, C is 8 ppm, and D is 12 ppm. So we can see that when the catalyst PHP increase, the zinc oxide flake will also be increased. And this result will be decrease the surface roughness, and at the same time, the reflection loss of the region will be effectively minimized, and show in this will show a superior in light trapping of this zinc oxide.
I'm going to explain about literature review for morphological characterization. Morphological characterization, also known as analytical imaging, which is an advanced form of high spatial resolution imaging that use advanced microscope to produce image of product and samples that cannot be seen with the naked eyes. These images are generated by the exposed surface of a sample. For example, homogeneity, size, shape, density, and surface of zinc oxide. Next is methodology for morphological characterization. FISEM stands for Field Emission Scanning Electron Microscope that used to study the density, shapes, interparticle spacing, homogeneity, and other properties of the grown zinc oxide nanostructure. Lastly, result for morphological characterization. From the figure, FISEM image of zinc oxide nanostructure grown on the ethos substrate. The corresponding electrolyte concentration are figure A shown for 0.05 molar, B for 0.1 molar, C for 0.15 molar, and D 0.2 molar. The FISAM image with the same magnification revealed that the grown nanostructure are cubic shape. An obvious change of morphological and dimension of the grown zinc oxide with respect to electrolyte concentration was observed in this paper. The size of zinc oxide nanostructure decreasing as the concentration increased.
I am going to explain about the electrical characterization of this journal. So first, the electrical characterization was carried out in a 4-probe productive cell. A constant voltage was applied to the sample and the current was measured using a gate electrometer. Current dependence on temperature were recorded during the cooling as well. When the sample reached the room temperature, it was taken to second heating cooling cycle. During the second heating cooling cycle, also the current dependence on temperature was recorded. The cycle curves were measured for films as grown and after annealing in oxygen atmosphere in 250 degrees Celsius. This is a gate electrometer. It ensures more accurate measurements of the extremely low current common in device and material research. Measures resolution on ultra-high resistance materials and insulators accurately. This is the result. So as we can see, the increase of average distance between the crystal columns affect the increased potential barrier at the green boundaries and thus increase resistance of the layer in the plane of the substrate. For the sample obtained after annealing, the clear and sharp increase of cross-resistance layer with increase of temperature is observed.
Hi, my name is Keng. I am from the Group 1 of the Material Characterization, and I will continue the project presentation. So I will introduce the optical characterization using the specialty instrumentation to extend the range, accuracy, sensitivity, and the precision to determine the material properties such as thickness. And mostly the application for the optical characterization is used in the light emission and detection, solar cells, photocatalyzing, photoelectronic and imaging, and the biosensors. And there are the two examples of the spectroscopy, which is the UV visible spectroscopy and the HTIR. The UV visible spectroscopy is used for the visible light to determine the concentration of the chemical in the mixture. And the Fourier transform infrared spectroscopy is use infrared light for the sample purpose. So next is the methodology for the optical characterization. Just now we have mentioned the UV visible spectroscopy, and we will use it to do it. And we can say the UV visible spectroscopy is an analytical technique that measure the number or discrete wavelength of UV or the visible light that are absorbed or transmitted through a sample in comparison to the reference sample. And mostly this is used for the bacterial culturing, drug identification, and the nucleic acid purity check and qualification. Also to quality the control in the chemical research. So for the next is the result for using the UV visible spectroscopy, and we can see the graph. This is the find the absorption and the wavelength for the ZNO, and can say the dependency of the absorption on the wavelength lambda shown by the UV visible spectroscopy, and the visible region is between the 119 to 919 nanometer. The optical band gap energy value of the film is approximate to 3.32 eV. This is a result for find with the UV visible spectroscopy. And this is all for the optical characterization. Hi, I will do the conclusion for the project. So in the conclusion, we have choose the electrochemical deposition method to deposit the zinc oxide film. And there are the three characterization methods, which are the morphological and electrical and also the optical to investigate. And in this study, the deposition method and tree characterization method have been introduced for use in the gene oxide thin film. That's all for our group one. Thank you.